Okay. You got this function, you want to find the inverse function. Remember what we did last time? I defined the inverse function for any of your basic functions is what you do when you switch those columns. So you're switching X and Y. Then we looked at the graph and saw how you switch X and Y. We didn't do that in a great deal of detail, but of course, I think you saw that explanation if you look at the open math videos, okay? So in the whole thing about that, Y equals X line and everything reflects across it, it all comes down to the fact you're just switching X and Y. So when you get to a formula like this, you just switch X and Y. Now we're going to if we're going to graph this, we're going to let Y be this. So Y is f of X or Y is 2X plus 3. They mean the same thing, okay? F of X, 2X plus 3, same meaning. So we take and this is the expression of Y equals f of X. Is Y equals 2X plus 3. Okay. And then we want to do the inverse function. So we switch X and Y. Where we've got Y, we write X. Where we've got X, we write Y. And this is the equation for Y equals F inverse. But of course, we want the formula for F inverse, we better solve for Y. So we solve this for Y. And how do we solve for Y? Well, we assume you know how to solve linear equations. Okay. Well, officially that's what we assume, but we know might have to refresh on it a little bit. Okay. Remember, if you got an equation, you can solve it. Basically 4 things you can do. There are a couple more, but right now there are 4 things. Another one is you do some square roots and squares and stuff like that. That gets a little tricky. So we'll say that just a little while. Okay. So for linear equation, you can solve it by adding the same quantity to both sides, subtracting to both sides, multiplying both sides by the same quantity, dividing both sides by the same quantity, as long as that quantity isn't 0. Is that familiar to everybody? Everybody aware of that? So it needs to be. If not, you probably need to do some review on that because we can't really cover that in class. It just isn't time to go back and do basic pre-algebra, elementary algebra stuff. Okay. But I give you resources to do that. And I can work with you a little bit on it just in the process of solving these problems. Okay. So here, what we have to do is solve for Y. Okay, you got X equals 2Y plus 3. Okay. I want to subtract 3 from both sides. Now, the way people like to do this, so I'm going to do it this way, is they want to put a -3 here and a -3 here. That's what people have been taught to do, I think. Okay. Now, I don't like that exactly. But if we put an equal sign here, then I like it just fine. Okay. Because what you're doing is -3 equal -3 a true equation? Yeah, it's true. And we assume this is a true equation. Now, if you got a true equation, that means this equals this, right? And this true equation means this equals this. Now, if this equals this and this equals this, then this plus this has to equal this plus this, right? When you add this to this, you have the same thing as you add this to this. I mean, if you write a true equation like 17 equals 17 and -5 equals -5, and add the 2, you get 12 equals 12. Okay. And I'm adding a negative. I'm not subtracting, I'm adding a negative. We never want to subtract equations if we can help it. Because if you subtract an equation with a negative in it, then you got a negative of a negative, and that's a big chance to screw up. Okay, we want to add. Okay, so anyhow, we add these and we get what? X minus 3. On this side, we just get 2y because 3 minus 3 is 0. That's of course why we did the minus 3, because we're trying to get y. We're trying to solve for y. So y is tied up with this 3 here. It's not tied up with that 3 here. Okay. Now I'm going to switch sides. Because if they're equal this way, they're equal this way. Okay, doesn't matter in which order we write two equal things, they stay equal. Okay, so we got 2y equals x minus 3. You got y. A lot of people want to subtract the 2. Well, subtracting 2 doesn't do anything. I mean, it doesn't affect this 2 at all. Okay, because you don't know what y is. 2 is multiplied by y. You don't get rid of a multiplication by subtracting. But a lot of people want to do that. Okay, so what we have to do is we're going to divide by 2. We divide 2y by 2, we end up with 1y, right? So we get this. And of course, now when we divide 2y divided by 2 is y. And that's x minus 3 over 2. Now that's exactly the same thing that the open math videos tell you to do. Okay. So presumably you're familiar with those, or haven't done the assignment. Okay. And most of you did at least that much of the assignment. You at least watch the videos. Okay. And some people didn't do the rest of the problems, but they've already done them in their class. Okay. So, you know, I can say, yeah, I think you're okay there, right? So that's what I want to say. Okay, well, there it is. So now we say that the inverse of x is x minus 3 over 2. Because again, when we switch, now y is the inverse, because y is the old x. Okay, when we do inverse functions, we switch x and y. Okay, well, there it is in a fairly simple example. You see more complicated examples in your course. And you know, if the algebra throws you, come in and ask about it, I'll show you. But we don't have time to spend a week on the algebra, right? So I can refer you to other videos, to other sources. I can explain it in here briefly, just like I did. Now, you understand what I did there? Now you know how to solve a linear equation like this. So you probably ought to do the rest of the assignments. Look again at the open math videos if you find them helpful. Okay. I don't always like the style of the open math videos, but you might. It's just a matter of taste. Okay. You might like the style of my videos better. You might not ever want to look at my videos. That's fine. Look at something. Okay. Find what you like and learn from it. Okay. And if you find something you think is really good, tell me. Okay. I can share that with somebody else. Nobody's ever done that, so I don't have anything to share, but you know, if you do, that would be great. Okay, assuming I can keep track of it, then I'd certainly make an effort to do that. You throw it up on the assignment page. Okay. Okay, now we want to check to see if this is really the inverse function. It's the inverse function. If and only if f of f inverse of x equals F inverse of F of X. Okay. And, well, actually, I could state that. I could say this equals this equals X for two reasons. I don't have room to write equals X. And then second, I really wanted to write that as two separate conditions because it's less confusing that way. Might not be confusing at all. So now we're going to check. Okay, so first of all, we check. I put a little question mark over the equal sign. I'm asking, is this equal to this? Well, what's F of F inverse of X? I'm going to write down what F of X is, because that's my template for expression F of F inverse of X. F of X equals this, 2X plus 3. So, for example, F of aardvark equals 2 aardvark plus 3, right? Now, if F of aardvark equals 2 aardvark plus 3, by darn, F of F inverse of X equals 2 F inverse of X plus 3. If it works for an aardvark, it's certainly going to work for something short like F inverse of X. X has been replaced by the expression F inverse of X. So I replace X literally by that expression. I don't do anything to it except put it in there where X is. Okay. Now, a lot of times people want to do all kinds of strange things with it because it looks like you ought to. And I saw strange things from several of you last time. Okay. Like if X is squared, you're going to want to square the X in here or something. Well, that's natural. You know, you see a square and an X, you want to see a square and an X, but that's not what it says. Okay. Or even a square on the F inverse or both. I saw all three. Okay. So if you did one of them, nobody did them all. If you did one of them, somebody else did another one, just as inaccurate. Okay. You got to really be careful that you just plug in the expression, nothing else. You don't do a darn thing to it. Now, this tells you you're going to do something to it. You're going to multiply it by 2. But you don't do that. You just write it out where it belongs. Whatever's here, whatever replaces this X, literally. I want to emphasize that because it's confusing. Yeah, personal. You know, I never saw an F of X in high school. I saw all kinds of stuff. We had a good course of logic, great course in algebra 2. I went away to a really, really tough school. Didn't offer anything below a really theoretical calculus course. They put me in that calculus course, not just in that calculus course, but with a calculus course with a real professor. Put me in the upper third based on my SAT scores of the class, and I didn't know what F of X meant. So I had to hustle. Okay, and I remember being confused on those very things. Okay, now I sorted it out pretty quickly, do or die. Okay. But I remember how confusing that notation could be. Okay. Fortunately, I had the rest of the skills I needed. So once I understood what F of X meant, I hadn't had a pre-calculus course either. I had the projection now. Didn't do real well, of course, when I got through. Okay. And then I built on. So, you come in with deficiencies, everybody does. I had one. Pretty big one. No pre-calculus. Didn't know what F of X meant. So if you got a deficiency, I understand it. If you got a deficiency with this, I certainly do. Okay. Personal recollection, decide. What do you do with this now? We've plugged in just the expression because that's what this says to do. This says you put in F inverse of X wherever X is, and that's what we do. Well, the next thing we do is we've got an expression for f inverse of x. So that equals 2 times x minus 3 over 2 plus 3. Okay. Now, 2 times x minus 3 over 2 is just x minus 3. This 2 divides this 2. And that's plus 3. And by darn, that equals x. Put a big check mark next to that, because that's what we're trying to test. Is this thing equal to x? Okay. There we have it. Now, you can do the same thing with this. So let me ask you to do that. I want you to see if you can do f inverse of f of x equals x. You want to start by writing the template for your f inverse function that we got there. Okay. And then we're going to do exactly what we did here, but it's going to look a little different because the form of the functions is a little bit different. Okay. So f inverse of f of x equals what? Well, x is being replaced by f of x, right? That means I have to replace this x by f of x. And everybody's having a huge amount of trouble doing that, because it's too simple. Okay? It's as simple as it looks. Okay? So you replace this x by f of x, what are you going to have there? You're going to have f of x minus 3 over 2. Now you have to see that this follows immediately from this. And you don't want to be looking at anything but this template and this expression that you're trying to test. Okay? You're trying to test whether this is equal to x. You write down the formula for f inverse of x. And then you write down what you're trying to evaluate, f inverse of f of x. You look back at the formula, you see f of x is replaced with x. So x has to be replaced by f of x. You just write it down. Okay? It's that simple. It's like you got little tiles. Okay? You got a little tile that says x, you got a little tile that says f of x. When you do this, you take that little tile that says x and you move it out and you put in the little tile that says f of x. Okay? But since you put it here for x, you're going to have to find another little tile that says f of x and put it here. Does that make any sense? If it doesn't, ignore it. Just make sure you know how to do this. If it does, it can help you see what's going on. If I had little tiles and you're really bored, I'd do for you. Never thought of that before. Okay. Now, what do we do next? After we've done this step, which is really, really simple once you see it, we take our expression for f of x, which is 2x plus 3, and we put it in here. Okay. Now we're almost home free. Because what's 2x plus 3 minus 3? Well, what's 3 minus 3? Goose leg. Okay. Right? And what's 2x divided by 2? Well, if you got 2 x's, you take half of that, you got 1. Okay, and that's x. Okay. And that's what we were trying to prove. And now we've proven that these are inverse functions. And now you should be able to do that for any linear function. If you can't, I think I've given a pretty good explanation from the beginning to end here. You got 10, 12 minutes of video, review it. Understand every word that I said, or find something else that explains it in a way that works better for you, okay? I think I've defined it right here for linear function, and in this course, if you do it for linear function, that's about as far as we go here. You go a little further in your pre-calculus course. You do it for, you know, square roots and squares and stuff like that. Okay. Okay. So, well, very good function. Failed off in a way that I didn't intend, but okay. The x equals -2 point. Now the x equals -2 point is not here. Because we're talking about a secant line for x equals -2 and x equals 5. We want the point on the graph where x equals -2. Okay. Now I've seen people do that, or I've seen people say it's here on the y-axis. Okay. And you know, in all cases, people have the right point over here. Okay, so here's, so that's the x equals 5 point. Everybody understands that. And let's say the x equals 2, but I'm going to cheat a little bit. I want this thing to be horizontal. Not exactly the projection line. Okay, but let's say here's the x equals 2 point, right? So here's the x equals 2 point, -2 point. That point is approximately -2,5. This point not 5, 6.5, right? Now we've got the secant line. That's really, really simple if you understand the definition of the secant line. Just a line between 2 points of the graph. A lot of people got the points. Some reason didn't want to go on the secant line. Maybe they're just offended by secant line. I don't think that's it. I think you just didn't know the definition. Well, you got it now, right? That's what a secant line is. Now, ask for the slope. I want to draw a picture for the slope. There's a formula for the slope, but I prefer the picture because most people understand it better from the picture. Okay. Here's a triangle. Okay. If I look at this triangle, well, actually, I'm going to draw the triangle again down here. I could draw either triangle. I do both. Distinguish the two. Let's do this. Okay. The green triangle's above, then it goes from point to point. The orange triangle below the graph, but it also goes from point to point. And I like that one better for this purpose because it's easier to label. I don't have room to label this side. And this side goes from -2 to 5. How long is this side? Well, you can count your fingers. -2, -1, 0, 1, 2, 3, 4, 5, 7, right? And of course, that's what you get if you do 5 minus -2. So here you run. Now we're going from this point to this point. So I'm going to put a little arrow there and a little arrow here to make sure I understand I've got a path from here to here. Otherwise, I might subtract them. Okay. Then from here to here, I've got the rise. Now my labeling over here is kind of in the way. So kind of with a little arrow here, the rise is, so what's the rise? The rise goes from y equals 5 up to y equals 6.5, doesn't it? There's the rise. And I'm going to actually put the 1.5 here. And then a little arrow from my calculation up there, so we're going out in the first place. So now I see what my rise is and I see what my run is. And it all makes sense in terms of the picture because 7's a lot bigger than 1.5 and this side's a lot bigger than this point. So now I can say the slope equals rise over run equals 1.5 over 7, and that's about 0.21. 214 something, okay? But we're estimating from a graph, there's no point in going any further than 0.2 or 0.21. Okay. I recommend that you actually, you've got a secant line and a slope, you actually do all this. Write out literally everything I've written out to reinforce what you're doing. Now, let me give you an idea of why this could be important. Let's say we got a lake. I'll Folsom Lake if you want a TVA lake, okay? Now, here's your water level in inches. And by water level, that doesn't mean how deep the water is. That means the water level compared to some post they got in the ground, okay? Or in the lake bed. It allows you to measure water level in inches above or below this particular inch. In actually a TVA lake, it might be in feet. Okay, so let's go with feet. In a natural lake, be more likely to be measured in inches. In a TVA lake where they drain it and so forth. X is time in days. Okay, in this case, what's the rise represent? What's the rise tell you between these 2 points? Okay, so well, we talked about it a little bit, but rise is changing Y. So change in water level is plus 1.5 feet. Run is change in time. Well, run is a change in X. Change the time and day. Change in X is plus 7 days, right? We've got plus 7 days, plus 1.5 feet. So the slope have room to write it all out. I think we're gonna wait even less. Change in Y divided by change in X. $1.5 feet over 7 days. It's 0.21 feet per day. So that 0.21 tells you on the average for that week, let's say it's 7-day span, how the water level changed. Now, the water level did a bunch of stuff between there because the water level was decreasing for quite a while. Then it came up and increased and ended up with a net increase in the level. Okay, so maybe running your turbines, you drain, and the rain started, and you eventually raise your water level. Other interpretations of this could be the Dow Jones Industrial Average. Okay. And over the week, it had a net gain of about 0.21 points per day. Okay. Although, yeah, you get a little nervous right there, but then, okay, so it goes down and it comes up. Ignoring what happens on an hour by hour basis or minute by minute basis, you do an average. So this is what an average rate of change is. So we could say that slope is your average rate of change of your water level with respect to time. It's an average rate of change. And that should help make sense of it and maybe give you some sense of the idea that it's really important. Okay. Okay. Here's a graph of f of x equals x squared. You know how to construct it. And you could do the same thing for any of the other graphs. Okay. I take several points on this graph, not necessarily the points that you graph when you do your standard function, just any old points. Throw a couple others in there. Okay. What's the point? And I raise them all up by the same amount. So there's an arrow, tells you I take this point and I move it up here. So I've got a new point. Okay, that arrow we call a vector. A vector is something that moves things from one place to another. The same vector applied here takes us up to about here. Now, I don't want to do all these points because vectors get kind of close together, but same vector. Same vector. So I get a bunch of new points. Now I've got a new graph. They've all moved the same distance. Points have all moved the same distance. And this is going to be, well, if the length of this vector if the vector has length 2, then this graph would be y equals f of x plus 2. Because what happens is all your y coordinates increase by 2, right? So if you start with f of x and add 2, your y has increased by 2. For every x, your y will be 2 greater than it was for the original function. And specifically, you have the graph of x squared plus 2. If you start with the graph of the same function, and you can do that's a bad graph, but anyhow, you do this for any function, okay? Let's say you want to move by this factor. Okay. Let's see, I want to move this thing all the way over. I'm going to move it. I'll move that far over. Actually, I think it should go. I'll move it this far over. Let's say this thing has a length of now I pick a bunch of points on the graph. And I move them all. Bring it back. I want to do there's one afraid about. We're just gone. I'll get these points. Well, no surprise, I get the same shape I have here, moved over 3 units, right? Okay, this is a graph. White graph is x squared. The purple graph is, now this is going to surprise you maybe in 2 ways, at least one. It's y equals f of x minus 3. And of course, if f of x is x squared, f of x minus 3 is x minus 3 squared. Okay, that should be starting to make sense to you. It's got to be that way. It looks like it ought to be x plus 3 squared, but it isn't. It's x minus 3 squared. I'll leave open math to give their explanation of that, and then I'll give you my explanation, which is probably a whole lot like theirs. Okay. There's another thing you can do. I'll do it real quick since I'm actually out of time. And I'll illustrate it with the squaring graph. Now what I want to do is I want to move every point twice as far from the x-axis. So what I'm going to do now for every point, I'm going to draw a vector. Okay, like for this point, I'm going to draw this vector here. You know, I'm just talking about an arrow with given length and given direction. Okay. I can move that vector anywhere I want to. What I'm going to do is I'm going to move that vector right on top of itself. And this is going to be a point on my graph. Okay. Now, what happened to the y value? It's going to be twice as great, isn't it? So, if I do the same thing here, of course, I've got a shorter vector that represents the y value, doesn't it? Okay. And if I add that shorter vector to itself, I get a point here. Now, this point is actually the origin. That vector has a length of 0, so it's not going to take a point anywhere. Then we do the same here. Same here. Do the same here. And now we've got these points, and we get a graph that's been stretched out. Okay. It's been stretched out enough to double all the y coordinates. And that's going to be the graph of y equals 2x squared if the graph of the original function was the x squared graph. Okay. Well, we can summarize this, but Open Math is going to do that for you. And I think they'll give a fairly good explanation of this. I think they're a little calculator dependent. You don't need a calculator if you use the points that we use. Okay. If you use your basic points, follow the whole pattern of what we do. Make sense of it. Okay. So this adds to whatever function you started with. This is a composite. You subtract that horizontal shift from x before you square it. And here you double whatever your function is. Okay. Those are transformation. Here's another one that we don't use that much until we get to exponential functions later in the course, so I don't emphasize it now. You get these three down, that's a good start.